Okay, so it certainly doesn't look pretty, but the assumption is if you got into this part in the course that you're working on, that you've done factoring before. I'm not saying the assumption is that this is no problem. It's certainly intimidating at first, but if you look at this and this and this, if you don't think you can do anything with them, that means you need to go back and take a look at your previous work in your course. But these are something that can be rearranged using a technique called factoring. And so what I'm looking for is I'm looking to write this in the form of two parentheses, and how I'm going to write it is like this. This is the factored form of this right here. Because if you multiply this out, it would simplify and turn back into this. So these two things are the same thing. And I came up with these two parentheses, because I started them off with p. That when I multiply the first numbers in the parentheses, it makes p squared. And then I needed two numbers that multiply to be 2 and added up to be that middle number 3. That's the technique that makes it work out, so that if you were to multiply, it would turn back into what you started with. Okay, so that's just a brief recap on factoring. Another technique is when you don't have a middle term. It's basically the same thing. You just need the two numbers that you're making on the outside to add up to be 0. So how about -2 and +2? Those multiply to be -4 and add up to be 0. Same thing with this one. What are we going to factor this guy to be? How about a +2 and a negative, whoops, I'm running out of room, and a -1. Because 2 times -1 gives us our -2, 2 plus negative, oh shoot, I got my signs wrong, don't I? Yeah, that looks better because they multiply to be -2 and they add up to be -1. So now that we've got that, clean that up a little bit. Okay, so let's take a look at everything that we have here. We would like common denominators so we can combine some stuff. But first, they certainly don't have common denominators. This one has a p+2, this one has a p+2, this is missing a p+2, so let's put that in there by multiplying it by 1 in the form of p+2 over p+2. So going right down the list, we got a p+1, a p+1, this one's missing a p+1, so let me see if I can squeeze that in there. I should have left myself some room. I hope you can tell what I'm doing there, but got p+1. I multiplied it by the form of 1 because these could just cross right out. It didn't actually change the fraction, but it's helping me get my common denominators. So this guy is just missing the p minus 2 from these ones. So we're going to want to multiply this by p minus 2, p minus 2. Okay, and now that we've done that, we have common denominators. So we could do a little simplification because since this is being multiplied, do we want to do that? Let's try leaving it first. Let's try just writing it out the long way. 5p minus 2. They're being multiplied together. I just put the 5 in front. And this is all being subtracted by 3p plus 1 from the other fraction. And remember, we can do this because now we have common denominators. You can just subtract the numerators when you have common denominators. So we had p plus 2, p minus 2, and a p plus 1 for that common denominator that we crafted. And over here on the right, that's just a p plus 2 over that common denominator again. The p plus 2, the p minus 2, and the p plus 1 that we worked hard to get. Yeah, so earlier I hesitated. I thought maybe it'd be better to keep it in the factored form, but it's not going to help us. Let's multiply this out, and then we'll see what like terms we can combine. Okay, so I multiplied them out. I made 5p. One thing I wanted to note, that's a -3 times a +1. That gives you a -3 right there. So let's combine those like terms. 5p minus 3p makes 2p. -10 minus 3 makes -13. Oh man, that common denominator is getting hard. Sometimes what I'll do, if it's in person, is I'll just put quotes here to say, hey, we had common denominators, let's just not keep writing them down. And I don't think any professor will be mad at you if you do that. Because mathematicians are lazy. So, one thing you could do is, I've been suggesting you could cross multiply, because you have a fraction equals a fraction, but that's going to be kind of cumbersome here. Here's a different idea. Let's take the right side and subtract it by itself to make it completely disappear and turn to 0. I'm going to subtract the right side by p plus 2 over b plus 2, b minus 2, b plus 1. Keeping that common denominator. I'm not canceling these out because I want to keep that common denominator. That way I can communicate this to the other side. I'm going to subtract this side. Oh, protect it with parentheses. parentheses. Subtracting this side by the same thing. I'm still doing that balanced step that we first studied in algebra when we were just subtracting 2 from each side, or an x from each side. Just a balanced subtraction step. It just takes longer to write because it's a bigger fraction. So what that's going to do is that's going to make this cancel out and make 0. Over on the left, since these are being subtracted from each other, it's going to be 2p minus 13 minus p minus 2. Because it's this stuff subtracted by everything that's in the parentheses. So what do we say? 2p minus 13 minus p minus 2. And you distribute that negative sign. And it's all over that same common denominator. And look, what you can do is you can multiply both sides to get rid of that common denominator. Multiply both sides by b plus 2, b minus 2, and blah, 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 blah. You multiply that over here, that common denominator, that gets rid of it. Hopefully you get what I mean. I'm just, my hand's cramping up writing that over and over again. That's going to cancel this out because it's in the denominator here. You multiply it, that will make it cross cancel. What you do to one side, you have to do to the other with multiplication. But 0 times anything is just going to make 0. So you've just simplified your equation a lot faster. You've got 2p minus, oops, I can actually simplify that, right? 2p minus 1p gives us 1p. Negative 13 minus 2 gives us negative 15. And that all equals 0 over here to the right. So writing's on the wall. P is going to be 15. And you can take that answer and go way back. Make sure you don't have a divide by 0 error anywhere when you plug that in. Like you plug 15 in here, no divide by 0. Plug 15 in here, that's going to be something big subtracted by something small, so no divide by 0 error, no divide by 0 error here. So if you're checking your work, you're just going to want to be careful about plugging 15 in everywhere there. That should be it. 15 doesn't sound right though.